Okay, the last thing we want to do with this problem of the loop going in a region of magnetic field is to get the force acting on the loop as it enters the region. Why is there a force acting on the loop when it enters the region? Because when the loop enters the region, we said there's an induced current. So the current in this part of the rod is going upwards. And remember, how do you get the direction of the force on a wire that has a current in it? The rule was I/L cross B. You put your fingers in the direction of the motion of the current, so upwards. You curl your fingers towards the magnetic field, then the force will be in the direction of. So the force, if you use the I/L cross B rule, the force points to the left. That's the force, the magnetic force acting on the rod, on this part of the wire. The left part, there's no force on it. So there's only a force on this part. And on this part, the L vector is in the same direction, the direction of L cross B is actually downwards for the top part, and for the bottom one, the current is this way, so L cross B is upwards. So these two cancel each other, and so the force that we're interested in, which is in the direction of motion, is this one, it's to the left. And the value of the force, the magnitude of IL cross B, is ILB, because the angle between L and B is 90 degrees. So you get IL times B. The current is E over R, and then you get E over R times LB, which is the EMF. Remember, we got the EMF was BLV, so you get BLV over R times LB, which equals to B squared L squared V over R. So what happens when the loop is completely inside the region with a magnetic field? Well, there's no EMF, there's no current, and since there's no current, then there's no force. So the loop actually will just keep on moving. You don't have no force is applied to it. It'll just keep moving with a constant speed. And then the loop is going out. We said the current is going this way. So again, this part has no force on it. The top part, let's see what the direction of the force is. The L vector is from the left to the right, and L cross B is upwards, so the force on this part is upwards, and here the current is from the right to the left, so the force is then going to be L cross B is down, and again they cancel each other out, and they're not in the ones we're interested in anyway. We were interested in the forces in the direction of motion. So what about this side? This side the current is upwards, so the L vector is upwards. So L cross B is actually to the left, and the value of the force ILB, and it's the same as before. The current is the EMF over the resistance. The EMF, we got it was BLV over R, so you get B squared L squared V over R. So in both cases, the force was to the left. The force that the magnetic field makes on the wire, on the loop, was to the left. That means if you are an external agent, and you want the loop to keep on moving with a constant speed, as the loop is going into the region with a magnetic field, you have to apply a force, an external force, with this value to keep the loop moving with a constant speed. You want the total force to be 0. And as the loop is going out of the region with a magnetic field, you also have to apply a force in the positive direction, an external force, with the value B squared L squared V over R, to keep the loop moving with a constant speed as it's exiting the region. If you don't apply these external forces as the loop is going in and as it's going out, then the loop will start to decelerate. It won't be moving with a constant speed. So you need to apply this external force as it's going in, as it's going out. When the loop is completely inside the region of the magnetic field, you don't need to apply any external force, because remember, the force was 0. The force of the magnetic force on the loop was 0. So you just leave the loop on alone. You don't touch it at all. You apply 0 force, 0 external force, because the loop will move with a constant speed anyway. So that's basically how the force, the external force, looks like to make the loop keep on moving with a constant speed.